Solar eclipses tend to be pretty big news. The 2017 one in North America was hugely memorable for millions of people, including the SciShow team. And the 2019 one in South America was equally amazing and Instagram-worthy. But during those events, the sky isn't the only thing people were looking at. They were also fascinated by these crescent-shaped lights that appeared on the ground, most noticeably underneath trees. The lights are one of the most fun parts of any solar eclipse, and the science behind them is pretty good, too. The biggest thing causing these lights is called the pinhole camera effect. Like the name says, it was originally used to describe pinhole cameras, which work by letting light through a tiny hole in a screen. But the same physics applies when light from an eclipse passes through the spaces between tree leaves. On the most basic level, light comes from the sun, passes through those gaps, and then hits a projection surface, usually the ground. But the important part is that not every ray of light is able to pass through. The only rays that reach to the ground are the ones angled in just the right way to make it through the spaces between the leaves. And much of that light takes a very specific path. It starts from one side of the sun, travels through the gap in the leaves, and hits the other side of the projection surface. So the light that comes from the left side of the sun ends up on the right side of the patch of ground, and vice versa. This creates an image of the sun that's both upside down and backward. And it's why those little blobs of light look so much like this solar eclipse happening way up in the sky. They're tiny images of the eclipse itself. Technically, this means you can observe this phenomenon regardless of whether an eclipse is happening or not. It's just that the sun, without the moon in front of it, looks like a circle, so its projected image is just a circle. Pretty nondescript. It's only once the moon starts getting in the way that things become all interesting and pretty. The cool thing about these images isn't just their shape, though. It's also the fact that they're really crisp and clear. Like, look at these lights compared to the blobs you normally see underneath trees. The normal lights are fuzzy, while the eclipse ones are sharp little moon-shaped things. That happens for at least two additional reasons. One is that there's less ambient light during an eclipse. Normally, sunlight gets refracted and bounces around in our upper atmosphere. That gives the sky its nice blue glow, but that glow is another source of illumination, which makes the lights and shadows we see pretty fuzzy. As the solar eclipse approaches totality and the moon moves completely in front of the sun, that additional glow is dramatically reduced. That means you don't get as much interference, so you get much cleaner, photo-worthy images. The other reason these things get so sharp close to totality is because the visible portion of the sun becomes narrower. Normally, the sharpness of a shadow depends on how far away you are from a light source. If you're really close to it, the shadow will be sharper, and if you're farther away, it'll be more fuzzy. But changing the size of the light source can have the same effect. When you decrease the size of your light source relative to the thing that's casting a shadow, like by covering up part of the sun, the shadows change. The ratio of things that are totally in shadow versus only partly in shadow increases, and that gives those eclipse lights on the ground sharper edges. So the next time you're experiencing a solar eclipse, take some time to look down. There's a lot that those funny-looking lights can teach you. And hey, if you're not willing to wait for the next eclipse, you're not out of luck. At night, LED streetlights shining through tree leaves can project some pretty cool pinhole images, too. So ultimately, solar eclipses are cool in a lot of ways. But in this case, they help highlight some of the amazing phenomena that surround us all the time. I hope you get a chance to check out these amazing shadows the next time you experience a solar eclipse, especially since looking at shadows is a great way to see what's happening without looking at the sun. Because, in case you've forgotten, that's a really bad idea. And we have a whole video that explains why, which you can watch next.